At this point, we know three methods for solving systems of linear equations. We can solve them by graphing, by substitution, or by elimination. Of these three methods, graphing is the only one that has any type of limitation. The limitation being that if the answer is not a nice integer, it's often hard to see on a graph, especially by hand and even in the calculator. So if the place where it crossed was, for example, 1/2, 1/3, that would be really hard to find precisely on the graph. And even just the fact that you need to be very precise in your slope and making sure your lines are drawn, exact, makes it much more difficult to get a good answer from graphing. So today we're just going to focus on solving by substitution and solving by elimination. Given these two equations, negative 3x plus 4y equals 12 and y equals 6x plus 3, take a moment to consider which method makes the most sense for you to solve. Would you want to solve this by substitution or by elimination? Now, when I think about this problem, I think to myself that I'd want to use substitution because I know that y is equal to 6x plus 3. Because y is already isolated in one of the two equations, it makes it easier to use a substitution method. So I can replace y in my first equation with 6x plus 3. Go ahead and solve now. So once I solved for x, I had to solve for y next. I chose to use the second equation, y equals 6x plus 3, because y was already isolated, so that's easier in my mind. I could have plugged it into the first, and I still would have gotten y equals 3 for my solution, but it's often easier to solve in the one where the variable is alone. Don't forget to write your answer as an ordered pair, always x comma y. Given the two equations, 2x plus 8y equals negative 16, and negative 2x minus 3y equals 1, think about which method you'd prefer to use, substitution or elimination. I'm going to go ahead and use elimination because when I look at this problem, the first thing I notice is my x's. One's a positive 2 for the coefficient and the other has negative 2. And when we have opposites like that, I can just add my two equations up and I can eliminate that variable. So go ahead now and solve this problem by elimination. Now, when I eliminated, I was only left with y, so I solved for that. And then I needed to solve for x, so I plugged back into my first equation, just because I didn't want to deal with the negatives involved in the second equation. But if I had plugged the y equals negative 3 into the second equation, I still would have gotten x equals 4. Given 8x minus 3y equals negative 10, and 3x plus 4y equals negative 14, consider which method makes the most sense to solve, substitution or elimination. I'm going to choose elimination because it's not that easy to get a variable by itself without dealing with a lot of fractions. Once you know you're going to be doing elimination, the next decision you need to make is which variable is going to be the easiest to eliminate. You can always eliminate either one, but sometimes there's one that's easier. I'm going to choose to eliminate the y's because one coefficient is already negative and the other is positive, which will make canceling them easier. So since I'm going to be getting rid of the y's, I think about what is the smallest number that both 3 and 4 go into. And since that's 12, I'm going to multiply my top equation by 4 and my bottom equation by 3. Go ahead now and solve this problem by using elimination.